welcome back to the channel. In this video, I am going to discuss one of the very important concepts in physics. Do you want to know what concept it is? It is called motion in a circle. So if you want to download the notes, because I have already uploaded the notes in the PDF form, you could download the notes first in order for you to go through. Whenever I go through, it is easier for you to write down your answer, to write down some important tips that I'm going to give you, and to write down some important information. And in this video as well, I am going to discuss some of the topical past year questions to make sure that you know how to not just understanding the concept itself, but also know how to apply the concept in answering the past year question related to this topic. So are you ready? Let us get started. First thing, which is very important in this topic, is actually, everything is related to circle. I believe you know this equation when you learn at math in your high school, right? So one of the very important term is called angular displacement with the symbol of theta. Now, the definition itself is very important as well. This is a definition, so you can copy down the definition if you have downloaded the PDF form, which I already uploaded. So the definition is the angle. So the angle, it is related to angle. That is why it is called angular displacement, angle turn through a particular direction measured with reference to the stationary horizontal line. To those who learn at math, you definitely know that I need two straight lines that intercept in order for me to form an angle. Do you agree? So I need two straight lines that intercept at one point here, just like this one, to form an angle. So the angular displacement is the angle that turns. But whenever we measure the angle, we have to measure the angle starts from the positive x-axis. Let's say, okay, this is what I call positive x-axis. Let me highlight this here. So whenever you form a straight line, this is point O, I call it, and let's say this is point A. If you want to measure the angular displacement between point O and A, right, you have to measure start from O to A. Or let's say there's another point. Let me use different color here to show you. Let us say that this is point B here. So if you want to measure the angular displacement of point B, all you need to do is just to take your ruler, start from where the point B is, draw a straight line to the center of the circle. And the angular displacement must always be measured, like what I say, with reference to the stationary horizontal line. Where's the stationary horizontal line? It is the positive x-axis all the way to where B is. This is what we call angular displacement of point B. I hope you get this. But if you face any difficulties, if you don't understand, do comment below. Right, so the SI unit or standard international unit of angular displacement is called radian. Right, and angular displacement itself is a vector quantity. What is vector quantity again? Vector quantity is a quantity which depends not only on the magnitude, not only on the numbers, but also depends on the direction. You see that angle must be measured with the reference of horizontal line, positive x-axis. So from there you measure your angle. That is what we call direction. So if you want it to be mathematically, angular displacement is theta, which is equal to S over R. Now, what is S represents? S represents arc length. Arc length is the curve length, which is being shown in the diagram that I have given you. And R is called the radius of the circle. Radius must be measured from the center of the circle to the surface of the circle. I hope that clarifies. Let us move on. 1 radian is defined as the angle subtended by an arc length to the radius of the arc. Theta is equal to S over R. That is 1 radian. Right. If you want to write equation in your definition, you are actually welcome to do so. But hey, you don't just leave it like that, because you have to put a comma here and explain every symbol that you use, then only in order for you to gain that full marks. Now, angular speed, or the symbol is called omega. So it is defined as the rate of change of angular displacement. Do you still remember speed that you have learned before, your angular speed in the kinematics or linear equation? Speed is defined as displacement or distance per time taken. So angular speed is related to angular displacement. Just put angular in front of it. Per time taken. Right? If you don't like this definition, you can write the change of angular displacement per time taken. It's not a problem. So the equation for this, you can write omega is equal to the change in angular displacement because you start from horizontal x-axis, positive x-axis, divided by the time taken. And you can add this, the unit of angular speed is radian per second. Why again? Because angular displacement is measured in radian and time is measured in second. And angular speed is a vector quantity. Remember that vector quantity. It depends on the direction. Why again? Because angular displacement itself is a vector quantity. Now, the next one, there is also a relationship between angular speed, period, and frequency. Let me do it one by one. Period, or the symbol is capital T. It is being defined as time taken for one complete. You like circulation, you can put circulation because this is related to circle. If you like oscillation, then you can put oscillation. Right, so mathematically, period is equal to 2 pi over or omega. Okay, I better write down. Okay, relationship between omega angular speed is equal to 2 pi over period. So if you want to put period as a subject, you could put period is equal to 2 pi over omega, any one of these. Period, the unit of period is still second. Period is a scalar quantity. All the time related to time are all scalar quantity. You do not have any directions for time, right? So all you need to do is just to memorize the relationship between period and or omega or angular speed. Or the other one, period is also equal to 1 over frequency. You have learned before in your high school. Right, another thing is about frequency. The symbol is small letter f here. The definition is the number of complete circulation made in 1 second. So, like, for example, like in 1 second, you time to time, how many complete circulation that you have made? That is frequency. So mathematically, frequency is the reciprocal of period. Frequency is 1 over period. Or in other words, okay, omega is equal to 2 pi f. Therefore, frequency is equal to omega over 2 pi. Right? All these are relationship between period, frequency, and as well as angular speed. And angular speed sometimes can be called as angular velocity. It means the same thing. Right? So the unit of frequency is hertz or Hz. Now, one serious question that I need to ask you here, which is very, very popular question that pop up in most of the past question, is that is an object considered to accelerate when that object itself is traveling with a constant speed? If you say yes, why? If you say no, why? This kind of question is a bit confusing, don't you think so? Because all this while, when you learn about the speed, you know that when the speed is constant, speed is always the same, the magnitude of the speed is always the same at all points. So the object is not moving any faster or any slower. So it should not be accelerating, right? Most of the students have this concept, which is definitely correct concept. But hey, you think about this. This is about circle, moving, traveling in a circle. Right, let me show you some diagram. This is a circle. Let's say there's an object traveling in a clockwise direction. circle, moving in a circle in a clockwise direction. And I want you to bear in mind is that if you, oh, this is anti-clockwise direction. I'm so sorry. Look at the arrow. The object is turning in anti-clockwise or anti-clockwise direction or counter-clockwise direction. Doesn't matter. So you look at point A. If you want to find the velocity at point A, because velocity means linear. Linear means straight line velocity. If circle is a curve, if you want to find the straight line velocity, you have to draw, oh, I want to find the straight line velocity or the velocity at this point, you need to draw tangent to that curve. That is the direction of the velocity. Let's say if I want to find the velocity at this point, point B, I call it, I just draw tangent. Why my tangent is going downwards? Because I have to follow the direction of circulation of this object. Right, this is the velocity. You know, at any points that I draw on the circle, if I want to find the velocity on the circle, you have to bear in mind that I have to draw tangent, and I want you to look at it very, very carefully. Even though the speed is the magnitude of the velocity. Maybe this is 10 meter per second. At this point, it is also 10 meter per second. At this point, it is also 10 meter per second. And at this point, it is also 10 meter per second. That represents the speed of the object is always constant. But hey, I want you to check out on this. Look at the tangents that I drew. Look at the arrows here. Represents the direction of the velocity. Don't you think that velocity depends not only on the magnitude itself, but also on the directions? Since the directions of the velocity keeps on changing when the object is circulating, right, around a circle, velocity must change. Owing to the fact that the velocity is changing, rate of change of velocity gives rise to acceleration. Don't you think so? That is why even though the object travels with a uniform speed around a circle, the object is said to be accelerating, owing to the fact that the direction of the velocity changes. Therefore, the velocity must change. So, when an object travels in a circle, its direction of motion continuously changes. Like what I drew here, you can see that. A change in the velocity will produce acceleration because the rate of change of velocity represents acceleration. And this also means that an object travel in a circle must experience acceleration, owing to the fact that the direction changes all the time. Which direction again? The direction of the velocity changes continuously. Now, let us look at centripetal force. What? Think it easy. Whenever you have acceleration, you need to have a resultant force. And when an object is traveling with a uniform speed or the constant speed around a circle, the resultant force is called centripetal force. Right. So this is the definition of centripetal force. An object can travel in a circle only when a force exerts on it. Keep on pulling it to maintain a nice circle. This force is known as centripetal force. And the direction of the centripetal force. Because centripetal force is not responsible in changing the speed of the object. It is not making the object moving faster or slower. That is why it cannot act in the direction of motion or in the direction of the velocity of the object, because when the centripetal force or when the force is acting in the direction of the velocity, object could move faster. Or if the force is acting in the opposite direction to the motion of the object goes slower. So that is why centripetal force must always act towards the center. So this is a circle. All you need to see is that this is a circle. I draw a circle. So this is the direction of a centripetal force, always towards the center, always towards the center of the circle. That is why it is being called centripetal force. And the magnitude of this force, because it is not a new type of force, it is just a normal force. Right, it is a resultant from a normal force, could be from the weight, could be from a frictional force, could be from any of the forces that you have learned so far. The magnitude of this force can be calculated by F equal to gamma. MA, sorry. Right? M represents mass, A represents acceleration. That is why I always say whenever there's an acceleration, there must be a force. The force in this case, when it keeps the object to move in a circle, the force is called centripetal force. Now, right, centripetal acceleration or the acceleration in a circle, right, can be calculated by two equation. Acceleration is equal to, let me highlight this for you, A equal to V squared over R. That is why when you want to find the centripetal force, just multiplies by M. MV squared over R, you have to memorize this. Or the other equation is mr omega square. Let me explain every symbol. V here represents the speed. You have to square it, the linear speed square. R is the radius of the circle. And centripetal acceleration can also be calculated by r omega square. So this r represents the radius of the circle. Omega represents angular speed. All you need to do is just to square it. A represents acceleration, right? So M represents the mass. These are all the equations that you have to memorize. So if you face any difficulties, just comment below. Now, and also please take note, centripetal force is not a new force or the separate force. It is the name given for the resultant of any other forces such as friction, tension, weight, normal reaction, etc. that causes object to move in a circular motion. And this resultant force must be directed to the center of the circle in order for it to be called centripetal force. And centripetal force does not change the magnitude of the velocity. It does not make the object move any faster or slower. It only responsible in changing the direction of the object so that the object can complete a nice circle. And the direction of this force, the direction of the centripetal force, is always perpendicular to the direction of motion. Or the direction of the centripetal force is always perpendicular to the direction of velocity. And there is no component of the force in the direction of motion. That is why centripetal force does not do work on the object. So it is not responsible to make object move any faster or slower. That is all about the uniform circular motion. If you face any problem, any hesitation, you know what to do, just comment below. Now let us apply the concept of uniform circular motion in some of the past year questions. I have two questions altogether, but if you need more worksheets, more questions, you could also comment below. Now let me read the question first. A large ball is made from part of a hollow sphere. A small spherical ball is placed inside the ball and is given a horizontal speed. The ball follows a horizontal circular path of constant radius as shown in Fig 2.1. The forces acting on the ball are its weight, W, and normal reaction force, R, of the ball on the ball as shown in Fig 2.2. This is it. The normal reaction force R is at angle theta to the horizontal. Now, A part 1, by resolving, you have to use a little bit of math, a little bit of physics, right? Resolving the forces. Resolving the reaction force R into two perpendicular components show that resultant force acting on the ball is given by the expression. Now, to make things easier, I want to refer to this diagram. I will draw out a triangle. Right, so could you see that R is acting in this direction? This is R. And go back to the slide again. Could you see that weight is acting downwards? So I follow. Weight is acting downwards. Do you still remember I told you about the resultant force has to act towards the center of the circle? So I have to go towards the center of the circle. Okay, this is called centripetal force. I put it as FC. So the theta is here. Here. So since I have already drawn, could you see that? I have already drawn my vector triangle, which makes things easier for me. So since they put F, so I would like to put F here. Resultant force is F, so I just put F here. Yeah, and then I use sine theta first to find. Sine theta is opposite, which is W, over hypotenuse, which is R. And then I put cos theta, which is cos theta adjacent, which is the force, over hypotenuse, which is R. So I have two equations. This is equation 1. This is equation 2. To find tangent theta, all I need to do is just to take equation 1 divided by equation 2, sine theta divided by cos theta, which is equal to, I better write this down for you, sine theta divided by cos theta is equal to tangent theta. So sine theta is W over R. Cos theta, I just invert it right away, which is R over F. Right? So all you need to do, what you need to do, this is my favorite part, just cancel. Right? R and R can be cancelled off. Therefore, you have tangent theta is equal to W over F. Cross multiply W is equal to F tangent theta. Ta-da! We have already proven. Feel free to pause the video if you think that I'm moving too fast. Now, the second part, state the significance of the force F for the motion of the ball in the bowl. What is the function of the force F, right? The function of the force F is to change direction of the ball in order for the ball to move in circular motion. That's all. Now, B, the ball moves in a circular path of radius. Whenever I answer the question right, because, sometimes I don't know which equation that I'm supposed to use. That is why I always write this on top. At least I know, oh, this is a radius. And for this radius, the angle, the theta is 28 degrees. Calculate the speed of the ball. Do you still remember that this is the theta? So I can use, okay, let us see how many marks given here. And we will decide, wow, this is 3 marks. 3 marks meaning to say that the equation itself is not easy. I am going to use the one that we have proven just now, right? So I'm going to use this. W is equal to F tangent theta. So I'm going to copy this back. Tangent theta. And I know that this resultant force is called centripetal force, F. To find the speed, there are two equations of centripetal force. One is mv squared over r. The other one is mr omega squared. But I'm going to use mv squared over r because the question asked me to find the speed of the ball. So I'm going to sub it in. W is weight, so I'm going to put it as mg. This is mv squared over r tangent theta. So if you do not understand, you can always comment below. So M and M can be cancelled off, right? So G is 9.81. V squared is the one that I'm supposed to find. R is in cm. We know that the speed, look at the unit of the speed. It has to be in meter per second. So I have to change this to meter. So you have to divide 100. So this is 0.14. Tangent 28 degrees. Therefore, make V as a subject. V is equal to 9.81 times 0.14 divided by tangent 28 and square root the answer. So your answer should be 1.61. I put it in terms of 3 significant figures. So 1.61 meter per second. Meter per second. So that's the answer for the speed. Now, the next one, question number 2. The Hubble Space Telescope was launched in 1990 into a circular orbit near the Earth. It travels around the Earth once every 97 minutes. I have to write down this period. A. Calculate the angular speed of the Hubble telescope, stating an appropriate unit. So angular speed, which can be related to period. Oh, I remember. Omega is equal to 2 pi over t. It seems like we have lack of information, but we have everything that we need. Don't you think so? T must be in second. So that is why I'm changing 97 minutes. 1 minute is equal to 60 seconds. So when you do it, you're supposed to get 1.08 times 10 to the power negative 3. What is the unit of omega again? It is radian per second. So 1.08 times 10 to the power negative 3 radian per second. That's it. B, part 1, calculate the radius of the orbit of the Hubble telescope. So if I want to calculate the radius, so I have to do, because this is 3-mark question, I have to do a lot of things because there are two information that I need right here. One is because the telescope is orbiting, okay, or orbiting the Earth. And there, because telescope itself has a mass. So the force between the telescope and the Earth is called gravitational force. Gravitational force is the only force that acts on the telescope because in the space there are no air particles to block, right, to against the movement of the telescope. So the gravitational force provide resultant force. So the resultant force on the telescope must be centripetal force because the path is circular. So gravitational force provides, I would say that in this case, it is the gravitational force that provides centripetal force. Gravitational force is gmm over r square. Centripetal force in this case, because the first part I have already calculated angular speed, so I'm going to use mr omega square. Now I have to do it one by one. You just cancel it off. And I have to find the radius. So I put radius as a subject. Gm over omega square is equal to r cubed. R is equal to, you just cube root gm over omega square. So you just cube root. Okay, let me continue right here. Cube root. Okay, let me move myself a little bit. Cube root. G is 6 universal gravitational constant, which is 6.67 times 10 to the power negative 11. M is the mass of the Earth. Wow, the mass of the Earth is actually 5.98 times 10 to the power 24. It is given, and the omega is 1.08 times 10 to the power negative 3. You have to square it. So let your calculator handle the rest. Your answer should be 6.99 times 10 to the power of 6 meter. 6.99 times 10 to the power of 6 meter. That's the answer. Next one, the mass of the Hubble telescope is 1.1 times 10 to the power of 4 kilogram. Calculate the magnitude of the centripetal force that acts on it. So, centripetal force, there are two equations. F is equal to mv squared over r. The other one is F equal to mr omega squared. I'm definitely going to go for the second one. You know why? Because I do not have the speed, but I have angular speed. So centripetal force is equal to mr omega squared. M is the mass of the telescope. R is the radius of the telescope, which I have already calculated. 6.99 times 10 to the power of 6. And omega is the angular speed of the telescope, which is 1.08 times 10 to the power negative 3. You just square it. Let your calculator handle that. You should be able to get 8.97 times 10 to the power of 4 Newton. So 8.97 times 10 to the power of 4 Newton. But let me just confirm. 1.1 times 10 to the power of 4, 6.99 times 10 to the power of 6 times 1.08 times 10 to the power negative 3. You square it. 8.97. Yes, 8.97 times 10 to the power of 4. That's the answer. And I hope with this application of the concept in the passive question, I hope you understand uniform circular motion in a better way. And you could also support me by joining or subscribe to my TikTok channel. If you need any of the news, any of the positive question discussed, all you need to do is just to comment below or join my FB group. I have some notes, PDF notes for free, right? So thank you very much for your time and hope you gain benefits from this video. I'll see you again in my next video. Bye.